Good morning, everybody. I'd like to welcome you to the Blue Vigil live stream demo for the Matrice M300 drone. Appreciate you taking time to join us this morning. We are really excited to put this on. Before we get underway, just a little bit of housekeeping. Please remember, this is being hosted as a Zoom webinar. Therefore, participants, you will not be able to be heard, but you can communicate via chat. But most importantly, if you have a question, and we'd really love to get your questions this morning, please use the QA function. You can find that. It should be right in the middle of your Zoom panel at the bottom. Just click on that, enter your question. Myself and Kathy will be monitoring those throughout the session today. And we will make sure that we answer all the questions that come in. To get things started, I'd like to go ahead and introduce our co-sponsor, Terrestrial Imaging. We have Chris and Mike Lopresti joining us. They've been a longtime dealer and do just a great job with customers and helping them understand what tethered flying is all about and the details with our system. So I'll hand it over to you, Chris.
Thank you, Carl, and thank you, Blue Vigil. We're excited to be here today, and I know everybody who's on this call is definitely going to walk away at the end of this feeling excited too. Mike, is there anything you wanted to add before we get started?
No, I'm just looking forward to this demo. We've been working with Blue Vigil for a long time now, and the team is great and the product's great. So I think you guys will see there's a huge value in their tether system. So
now
you ready?
Yep. I was just a special shout out I know it's somebody else may do it as well, but to Dave DeLue and Captain Joe Green from Ocean County Sheriff's Office, because without them, we wouldn't all be this far advanced with the M300 configuration. So thanks, guys.
Thank you.
Yes, absolutely. Big thanks to the guys from Ocean County. They've been our launch partner and helped us with a lot of the early development and testing that went into making this M300 solution available. To kick things off on our end, I want to do just some quick introductions of our team. So again, myself, Carl Miller, I head up our partner programs. With me in the back office, I've got Kathy Welt. She did all the behind the scenes work making this live stream happen. And then out in the field, we have a 3-person team, Todd Stave and Gerard Eldering, who are doing some flying and filming. And now I'll hand it over to our CEO, Robert Schumann. Rob, we need you to go off mute.
Oh, you're right. I am on mute. So, okay, let's try this again. Good morning, all. Another fine Zoom moment. Thank you all for taking some time this morning to join us, and look forward to telling you about our new M300 solution. And before we go there, though, most of you may or may not have much knowledge of tethers or of the RS1000 system, or our Blue Vigil tether in particular. So let me take a moment and kind of talk about the pieces and the parts, and then we'll get to the M300 parts. So this here is the base station. So the tether component consists of a base station, and the base station takes AC power in, and that power can come from a wall plug, regular 15 volt, 15 amp outlet, can come from a generator, or can come from a inverter source. Doesn't really matter. It just comes in as AC to the base station. The base station then converts that to 400 volts that gets sent up the tether, and that's how the power is transmitted up to the drone during flight. And that 400 volts is there, so this tether can be small and of a size that the drone can actually lift and carry and deliver. And then these boxes come in 2 versions. They come in a 150-foot tether, the RS1000, and a 300-foot tether version as well. And then the last and most important part that this box does is that this box actively manages the tether. So it basically is keeping a fixed tension on the line at all times. And we'll show you a little bit more in as we go into the demo where that's important. But that's how we compensate for wind gusts and are able to fly in windy conditions without putting undue stress on the aircraft in the air. So we'll get to that. So you have a complete system consists of the base unit, and then 1 or more air modules, depending on what you're flying and what's in your fleet. From a DJI perspective, when the first DJI system we supported 4 years ago was the Inspire 1. And like all of our systems, it consists of some way to connect into the battery and the power delivery system for the drone. In the case of the Inspire 1, that was actually physically modifying the battery so that you could put in a 6S power source into the battery. And then the second component is what we call our BRM. And this component takes the tether at one end, the 400 volts, and converts it to the 24 volt 6S at the other side. And so flying the Inspire 1 is as simple as the battery, which you can fly completely normally. Or if you're going to go on Tether, you just slide in the BRM, you connect, oops, sorry, got to get this right. You connect the low voltage, and then you would connect the tether. And the tether connects two ways. One part is you have an electrical connection, which brings up the 400 volts. And then the second part is actually the physical mount point. So on the Inspire 1, there's actually already a nice bar here, so you don't need to do anything complicated other than to make this mount point. But this is where the power and the force is transmitted from the cable to the drone, because you don't want any force on the electrical connection itself. This is relatively fragile compared to the physical mount point. Also, you want the pull point to be in the center of gravity in the device. So that was our first system, was the Inspire 1. As you can see, our next generation solution was for the Inspire 2, not the Inspire 2, excuse me, the M300 and M210. And here we've gone to a little bit different system. In this system, we've created these sleds, and these sleds are basically, that's just what they look like. And what they do is they sit and they slide in just like a battery. And I'll do it on this side where we can see it here. Hang on a second. They take this BRM off. So, but they slide in, as you can see, they slide right in just like the battery. You push them in, you clip them in. And then again, we use the same BRM as is used in the Inspire solution. And it's got a nice mount on one side, so you can physically mount it in there, and then you would connect your tether, okay? And you get a sled, you get two of the sleds, you put one on each side, and then there's a Y cable to connect it all together underneath, okay? It makes for an easy flight. You can actually fly in this configuration without any need to, you can fly in this configuration without a tether at all, and then you can take the tether on and off. And we'll show you how that works in the M300 solution. So the M300 solution is our, obviously our next, our latest generation, which we're currently announcing. Very similar design in terms of the sleds. You can see here, we've actually taken the batteries that would normally be horizontal. We've created these sleds where the batteries go in this orientation. But what we've done here is that we have integrated the BRM into the sleds themselves. So for the M300 solution, all you need is the two sleds and then the brace underneath for connecting the tether itself, okay? And so what we're going to do is we are going to fly this guy first, and then we'll come back later and I'll show you how the components mount and how they load on in. And I'm going to turn it over to Todd Stave now, who's our pilot in charge today.
Hey, thanks, Rob. So I'm going to go through a little bit about flying this M300 aircraft. It's got a Zimu's HT20 camera, the zoom with the IR, and it's a 200x zoom. It's a fantastic camera. I'll play with it. I'll show you a little bit. But let's go through it. We have it all powered up here. And what I'm going to do, just so you can see, is I'm going to switch the camera here from the external camera that we're showing to what I see on my screen. And just in the corner, I'll put a little picture-in-picture so you can see what the external camera looks like as well. So here we go. Now, as part of the initial checklist, what we suggest everybody do is you take off, whoops, and that's exactly what it is. We have the cable tangled up in the landing gear there. Oop, okay, we're good? Yeah.
You're clear.
Are we? Down. There we go. Okay, good. All right. So we have the cable. We take off. Just stay here for about 5 feet, 6 feet above the ground. What we're looking for here is, if you notice the counter for the flight time, we want it to look normal. We wanted to make sure that both batteries are showing green. We wanted to show like the aircraft is flying as if there was no tether system. Now we're going to power on the tether so that we verify that the batteries are working, the flights are normal. We're going to power on the tether. Okay, you're gonna see a little bit of a dip in the drone there. There you go. Back up again, and we'll go into that a little bit more later. But before we climb a little bit, what I want you to pay attention to now is how rapidly that flight counter is climbing up. All right, and it's going to get to over 300 minutes, which, if you think about it, makes no sense whatsoever when you're talking about a flight that is not being powered by a tether or some sort of external power source. So I'm going to climb up to about 40 feet here. And we tell people they really need to climb quite slowly because the payout speed on the schooling system is about 1 meter per second, about 3 feet per second. This drone can climb much, much faster than that, and it's not going to do you any good to try to climb. You're going to just put stress on the drone. You're going to put stress on the tether. So fly gently is the credo here. So here we are with our camera. We got a nice view of our field here in rural Maryland. And we got the camera now focused on this scene here. I'm going to zoom in on that pickup truck, and then I'm going to zoom in some more to make sure that chicken is not trying to steal the pickup truck. No, looks like we're good. Okay. All right. We want to make sure this pickup truck is not on fire. We could always change it to the IR view. We want to see if there's anybody in the pickup truck or in the barn. The IR view is very, very useful. And we can zoom back out again. It's a very, very cool camera. Excellent with this drone. I mean, just really, really useful. I've had this thing 2 miles away at 400 feet in the air, and I could see a license plate. I mean, this is a really, really nice camera once you learn how to use it properly. So,
Stability.
okay. Oh, yes. The other thing I want you to focus on, and I'm going to just switch back to the external camera here for just a moment, is take a look at the cable. Notice how stable it is. All right, there's no vibration. There's a little bit of minor correction with the wind as it goes back and forth. But as you go back and take a look at the camera, and I'll zoom in again just to show you, because the reason I'm going to zoom in is because now you have a very fine point of focus here, which is far away. Flying on the tether does not in any way reduce the stability of this camera or this drone. It's rock solid. It's not moving at all. And you could stay here if trying to surveil a situation or a crime scene or an accident or anything, and just all day long without having to worry about it doing anything other than what you want it to be doing, looking around in the places you want it to be looking. We can move the camera on the gimbal. We can focus in, on that chicken there, and zoom in even further if we want to. Fantastic, and it's very, very rock solid. It's a 20x zoom right there on that chicken from 40 feet here. Okay, I'm gonna switch back again to the external camera, and what I want to highlight now is what happens in the event of a wind gust. So it's not a particularly breezy day here in Maryland. A little bit of a wind, but if it's really, really breezy, what's going to happen is the wind is going to take that tether and bow it out just a little bit. In other words, it's going to respond to the wind. Okay. Now, when the wind dies down, the tether goes back. And go ahead and pull it out again, Rob.
Mm-hmm.
All right. Switching back to the camera again. Notice Rob's got it pulled out. Switching back to the camera on the chicken. Still rock solid. Not going anywhere. Okay. One last thing I want to show you, and we're going to come back down now. Okay. Now, we always have questions about what happens in the event of a power tether failure. And so this is what we're going to demonstrate now. We are flying on tether. And once again, before we turn the thing off, I want to show you real quickly. This is what the flight counter now looks like, 316 minutes. Okay. We're going to turn the tether off and show you what happens, exactly when that happens. Go ahead, Rob, shut it off.
Okay, great. So keep your eye on the drone. So what we're going to do now is you can lose power. Say you're running off a generator runs out of gas, and you can have power loss. Somebody pulls a plug out inadvertently, whatever the case may be, okay? And we're gonna simulate that by just literally turning off the power switch on the RS-1000 itself. And when I do that, right now the batteries are electronically disconnected from the drone and we're running purely on tether power. And those sleds we have in there will detect the loss of tether power, automatically switch back to the batteries. And when that happens, if you watch the drone, you'll actually see a tiny little dip in the drone. It'll actually go up instead of down as it switches to batteries. And we're going to do it on 3, 2, 1. There you go. And then the drone settles back to where it wants to be from a GPS perspective. And this M300 is actually staggeringly stable in this configuration. So now we've regassed. We got the gas back in, the generator's running again, and we're going to turn the tether back on again. And here you're going to see now it's going to dip a tiny bit as the tether takes control. And then it's going to climb back up again. So now we're just about ready to go on tether, and there, boom, the tether just kicked in, and now it's climbing again, and we're hovering completely on tether. And I don't know if Todd was showing the control system, but we can take it back.
Let's do that again. Hold
Okay.
on, hold on for a second. I'm gonna let this counter. I'll switch back over to the drone.
Okay.
And you can see that we turn the tether on. The flight counter is climbing back up again. Go ahead and shut it off.
Okay, shut it off.
All right. All right. And now we're running on battery power, and you can see the flight counter dropping down back to something that's going to resemble a normal battery operated, battery powered flight.
Okay. You want me to turn it back on again?
Please do.
Okay.
Yep, we're good. All right.
There we go. Turn it back on
turn
again.
it back on, and you're going to see the flight counter go back up again. Now, this flight
There we
counter,
go.
just so you know, is simply an algorithm that is put into the system by DJI, which basically calculates the rate of depletion and gives you some estimate of what it thinks, how much time you have left based on the conditions that you're in. The wind, the payload, whatever you've got going on that make it vary. And so it's super confused right now because it's not depleting at all. The battery is actually logically disconnected from the drone. The drone is working on a power that comes from the tether, and it is not depleting in any way. The voltage is not varying, it's staying exactly where it is. So that's why you're seeing something that makes no sense on this particular application.
Yeah. And
okay, is that it?
One item to note as we're flying here is that we engineered this system, and we're very happy with the results, that it does not impact any of the sensors on the drone. So we do not have to turn off any of the safety sensors, even the downward facing sensors. So this M300 is flying with all of its normal safety complement in place. In terms of all the sensors. Obviously the top, there's nothing there, but even the side sensors and the bottom facing sensor are not impacted by being on tether. Okay, and then Todd, do you want to bring it down and we can show how quick it is to disconnect it? There we go. So now we saw something on our mission that we want to go explore, and we want to disconnect the tether so we can take off again and fly off of tether. And to do that, we landed. All we're going to do is turn off the tether. And then all we have to do to convert to normal flight is disconnect the electrical connection here. And then we need to disconnect the mechanical connection at the bottom. There we go. And pull the tether out of the way. And notice we haven't even turned the unit off. So the M300 is actually still operational, and now we're ready to take off again. And now you're complete autonomous. But again, the sleds will revert to the battery if there's no tether, and so the drone can fly completely normally in this configuration. Okay. Yeah. Yeah, let's bring it back down.
All right, before I bring it back down, once again, I point out the flight counter. It's showing that this is a normal battery operated flight. The sleds have nothing to do whatsoever with the fact that there's no power going into it. it's a complete pass-through at this point. So they're not in any way taking away any power or reducing the amount of flight time you have available from a normal operation.
Great. Then if you want to bring it down, and we can show the components. And before we do that, I don't know, Carl, are there any questions that people have put in?
Yes, we have one so far. This is from Eric. Eric would like to know how many max watts does the system draw? And does the power have to be a pure sine wave?
Yeah, so this system, the RS-1000 today can supply a maximum of 1600 watts sustained with about a 2000 watt peak. That capability does not need to be sine wave. We have plenty of people who use, basically the low end generators. So you don't need absolutely a pure sine wave, or also off of the inverters, where that tends to be a very important component. But you do need, depending on the drone you're flying, the power needs are a little bit different. The M300 needs 1300, 1400 watts. It's a pretty heavy solution, particularly if you're flying with a payload. So we can fly in the Tether with all of our equipment on it, all the Tether equipment on it, and then carry an additional 4 pounds of payload, at least. So that's what we've tested it to, and the combination of that is actually more than the rated payload of the unit. So in here, we're flying in this configuration today. We're flying with the H20T, which is pretty much one of the heaviest of the standard DJI cameras as well. So yeah, so that's the, now if you're flying with a smaller drone, if you're flying with a Inspire 1, there your power need is probably closer to 700 or 800 watts. A much smaller drone, much lower power draw overall.
All right, so in our poll, we asked people to identify kind of their biggest concern about flying on a tether, and the biggest concern raised was regarding windy conditions, which I think we covered. The next one was around tether cord breaks. Rob, how strong is the tether?
So the tether itself, if you're taking the tether and you're just pulling on the tether, this tether will, I think we did brake tests at it, it breaks at around 200 or 300 pounds of force. Okay, there's no way you're going to accelerate the force onto this. From a cutting perspective, if it gets into the blades, it's certainly possible for it to be cut. It's pretty strong. It's got a strong nylon outer shell, but it's certainly possible for it to get cut at a full speed spinning blade. But in terms of sheer strength and just holding strength, it's not going to go anywhere. I've literally watched a drone when we were doing testing with a partner. They were actually out on a ship, and the drone had a malfunction, and the drone went into the drink, and we literally dragged the drone back into the boat with the tether, and we're able to recover the drone in that scenario. So the strength of the tether is usually not the issue in that scenario.
All right, we had a few people that responded to the poll and selected their concern being other, meaning not specified. We'd love to respond to those concerns. So if you put those into the Q&A, we will make sure that we address those other concerns. We do have another question from Christopher asking that when we are ready to descend, is the tether actively retrieving the drone, or does the drone land under its own power?
The drone lands under its own power. So what happens when the drone starts coming down, just quite frankly, like in the wind example we did, where when we simulated let the wind gust going away, the base unit will detect that there's no tension on the tether cable, and will start reeling in the cable. So the drone can basically come down at whatever speed it wants. We highly recommend that you go relatively slowly so that you don't end up with the tether laying on the ground, because the tension is relatively small, and if you get 30 or 40 feet of tether on the ground, the friction of the tether on the ground may be more than the unit can really pull in, and so it's much better to come down relatively slowly and let the unit reel in. Note that that's, we pull in at about 3 feet a second. And so if you're at 150 feet, it's less than a minute to bring the drone back up and down in this scenario.
I would also like to add that if you are in an emergency situation and you have to land quickly, then land quickly. We can always get the tether back in the case without too much trouble.
Exactly.
Yeah.
Exactly.
All right.
So,
I missed this one when we were talking about tether strength. The question is, what happens while I'm flying on tether and something catastrophic happens, the tether comes disconnected or breaks while in flight, so I'm in a flyaway situation. What should a participant expect to happen?
So let's just say the tether just breaks arbitrarily. I don't know why it would, but let's just imagine the tether breaks, falls to the ground. There's 5 feet of tether hanging off the bottom of the drone. What would happen in that scenario is the drone would continue to hold its position. These DJI drones, if you're manually flying, right, you'll have to react. But assuming you just have a drone that's holding position, the drone would continue to fly. It would switch to battery, and it would just hang there. And eventually, it would get to its low battery level, whatever you set that at, and then it would auto land back just like it normally would in a normal loss of battery. One of the things that folks do when they're flying on tether on the M200 and on the M300, because we're completely isolating the battery from an electrical perspective, you can actually set your battery warnings at very high levels. You can say that I want to auto land at 50%, or I want warnings at 50 or 60%. And that way you get early warnings and quickly you're notified if you have an issue with the tether.
So I know you just covered DJI, but because we fly on a variety of other drones and configurations, if you could just quickly cover kind of what Ascent is doing in terms of batteries, and then some of the configurations that we've seen that flying without batteries.
Yeah, exactly. So we have some folks who fly without batteries. There, obviously, if for whatever reason you lose tether, you've lost all power to the drone, and you're going to have a catastrophic collapse out of the sky. But in other scenarios, one of our partners, Ascent Aerosystems, they actually put a very small battery in. So they replaced the large battery, put essentially a small backup battery into the unit. And that way they don't have to carry the weight of the large batteries and are able to still have a battery backup, but use the full power of the tether.
Yeah, so just to clarify, on the DJI, you don't have a choice. You're always going to be flying on a battery with the DJI drones, but some of the other drones out there, people are doing custom applications or configurations, and there's definitely a trade-off with weight and payload and batteries. So in the case of Ascent, in order that they can carry more payload, that's why they switched to a smaller, just backup battery versus using their regular size battery for operation.
Exactly, and that can become important if you have scenarios where you're trying to carry up a communications relay or something where you have a little bit heavier payload than you would normally have, and there you might want to lower the overall battery weight. But again, in the DJI ones, because DJI, they won't fly without the batteries in place. Obviously, you need to have the batteries there, the full complement of batteries. At this point, DJI has no options for essentially lower capacity batteries. So
here, we have a question while we're on the topic of payloads.
Yep.
Are there any, with the DJI drones, are there any constraints when you're operating under tether in regards to payload, either payloads that can be utilized or in the operation of any payload?
Really, there are effectively, we've seen no real constraints as long as you're within, obviously, the weight limits of the unit. Excuse me. We have seen one one interaction where a customer had bought both our tether configuration as well as a parachute configuration, and both of those used a sled type of design, and those two sleds are incompatible. So we're going to be working with that parachute company to figure out how we integrate and combine those two sleds into one. But that should be fairly straightforward. But that's a pretty unusual situation. In terms of otherwise, there's really no impact on payloads otherwise.
All right, and David would like to know if you can operate the Blue Vigil tether in the rain.
Yeah, so the modules for the M300 are designed to be IP55, so they're designed to the same capability of the M300 itself. So they can be rained on, and all of that is a design constraint to match this aircraft. The M200 cannot be flown in the rain, and it's our modules there also are not designed for that. Our base unit, the RS-1000, this current version is not weatherproof, and so if you're going to fly in the rain with an M300, you need to kind of get the base unit under cover, and then you can fly, and you just need to get the tether. You can come out at a bit of an angle so that you're not raining directly onto the base unit. A little light mist and all that, that's fine, but you can't really, it's not designed to get wet inside to any significant degree. We will at some point in the future, probably next year, be coming out with a base station which will also be weatherproof.
And Rob, a couple questions that we got in the last demo that might be interesting for people in this demo. In regards to warranty, is there anything that Blue Vigil does that would cause any warranty concerns?
No, we don't, and let me show you why on the M300. So in this M300 configuration, right, we have the two sleds, and then we have a Y cable underneath that connects them. So this Y cable comes together, connects the two parts, and so we'll unclip that. And so the batteries are the completely unmodified TB60 batteries. Okay, so there's no modification to those. The sled, and you notice the regular clip there for the M300. The sleds come out, the sleds slide in just like the batteries do. So there's no modification to any of this part. We haven't modified anything there. So there's no changes that would affect warranty or any other issues. And then the last component that's here is the mount brace underneath here. This is again where the force from the tether is transferred to the drone, and that's this gray brace you see here. And that gray brace screws in the sides in two of the screw holes that the legs normally are also held in. And again, that has no impact on warranty. We're just essentially replacing two screws and putting this piece on the outside. Normally, you would keep this brace in place permanently on the drone once it's installed, but you could easily remove it, put the screws back in, and deal with that. Otherwise, there are no modifications to the unit whatsoever in the process. And just to clarify, the air module kit for the kit for the M300 consists of two of the sled modules, the Y cable, and the brace. So that gets you everything you need to fly the M300. And then obviously you also will need a base station to go with that.
And in terms of tether flying, Rob, can you explain one, what constraints do people have? Are they required to be just stationary and hover, or can they travel some distance? And then what type of in-flight warnings, etc., come from the Blue Vigil system?
Yeah, so when you're flying, you don't need to be directly over the base station. You can, if you get to 100 feet, you can easily go over 50 feet in one direction, 50 feet. So you can get a bit of an operational circle. Obviously, you're constrained by the mechanics of the being on a tether. You can't go for a mile flight, but you absolutely can get some rotation and get some space. And so if you need to set up the tether, if you're at a big fire or something, and the tether has to be set up over here, and you really want to get a view that's 50 or 60 feet over, you could absolutely do that. And again, the unit will keep a strong tension. So if you're flying diagonally over there, the unit will still keep the tether nice and taut, and you won't get you'll still be in a safe operating configuration. Okay. The unit itself is a very simple user interface, but it will warn you as you get to the end of the tether. So as you get up near the end of the tether, it will start to beep pretty loudly at you. And there's a secondary visual warning on the tether itself that there are red bands that are in the tether as you get near the end. And then when you get to the end of the tether, the unit will get louder and a little bit more insistent about what's going on. And then you'll also, obviously, the drone will change tenor because the drone will now be pulling against that tether. And remember, the tether will break at 200 pounds, which is way more than the drone can pull. And so you're going to get motor. It'll be really obvious when you're flying that you have reached the end of the tether. If you're flying in windy conditions, again, that wind is going to pull that tether out some, and you're going to get a bow in that tether. And so you need to make sure that the height you're flying at is low enough that you could add, 10, 20, maybe 30 feet of tether. Because if you get a tether that's bowed out 15 feet, that takes, 30 feet of tether or so to make that bow happen. And you need to make sure you're flying low enough that you don't get to the end of the tether as wind gusts come and go.
Excellent. Just a last couple of questions. One that came in is whether a Part 107 license is required in order to operate a tethered drone.
So generally, yes, it is required. There is an exemption for public safety use. So if you're a public safety officer, I believe, I'm not sure it's exactly officer, but if you're doing it for public safety purposes, you do, and you're on tether, you do not need to have a Part 107. But regular other rules about night flying, you got to make sure people know if you're doing night flying and things like that, all those normal rules apply. And that's US. Other countries obviously have their own set of regulations.
All right, excellent. Well, it looks like that is it in terms of questions that we got from the attendees today. So I just want to thank everybody for joining us this morning. We are, as I said, super excited about this latest addition to our product line. And wanted to let you know that if we are about, in terms of product availability, we are about to start a final beta test. We still have a couple slots open. If you're interested in joining the beta program, talk to Chris and Mike, and they can fill you in on the details. There's a nice discount available for you if you choose to go that path. And lastly, just a reminder about Blue Vigil. We are a Virginia-based company, and our product is 100% made here in the U.S. So again, thank you. And I'm going to turn it back to Chris and Mike one last time before we close out.
All right, fantastic demo, guys. Really appreciate it. And thank you for everyone for participating. So all participants today are eligible for a $500 discount off of an M300 Tether purchase from Terrestrial Imaging within the next 3 months. So if anyone has any questions, we're available at any point. Give us a call, send us an email, and we'd be happy to help you guys. Thank you so much for attending.
Thank you. Have a great day, guys.
Thanks, everybody.
It was very effective.